The question talks about a function which maps AB as BA. So basically it's mapping A Cartesian product between A and B to elements in B and A. So this is your input set and that's your output set. Basically a Cartesian product which generally looks like this. So this is your input set, remember. All these are your input set. Is mapping to this particular output set. Basically like this. So what is the difference? There we saw it was a comma 1, here it is 1 comma a, 2 comma a, 3 comma a, right? So that's the difference. It's flipping the order. So let me write an example to make it a lot clear. F of, say we have 4 comma true, it will map to true comma 4. Okay, so this is what you need to understand before we start off. So we need to show that it's bijective, means it's 1 1 and on 2. So we have to show, so basically it's true, we just have to write that it's true. So we'll consider we have two input values which are part of A and B, A cross B, that is. So we have D and say E, which belong to A cross B, the Cartesian product between A and B, such that they will point to the same output. So I can equate them. Now, with this in mind, what can I tell? Therefore, A, B comma A should be equal to E comma D. So on comparing the order pair, what can we tell? On comparing the order pair, what can we tell? Well, B will be equal to E and A will be equal to D. So B is equal to E and A is equal to D. So from this I can tell that A comma B is equal to D comma E. That is, the input values which we started off with are the same. So from this I can tell that f of x, in this case f of A comma B, is 1 1. Remember, these are your input sets. The inputs are same. Now next is onto. How should we talk about onto? So it has to do with all the possible values in the codomain. So let's talk about, consider B comma A that belongs to Cartesian product between B and A. It represents arbitrary values at the codomain. Now from this what can I tell? Well, B has to come from set B and A has to come from set A, right? So basically with this can I tell that A comma B should come from Cartesian product between A and B? Is it not? It has to. So finally I can tell, thus for any value at the codomain, which is B comma A, we have a value or values, in this case value only, at the domain as a comma b, such that so when I give this input to the function, it will give me the required output. And so from this I can tell f of a comma b is onto. And finally the whole f of a comma b is bijective. Hence proved. Okay, yes. So this has to be very clear, as we are looking at Cartesian product, not your normal input values. So here the values that are related are product of Cartesian product, right? So I'll repeat this again. So this being the input set, if I give an input of a comma 1, a comma 2, a comma 3 and so on and so forth, I'll get an output of 1 comma a, 2 comma a, 3 comma a, so on and so forth. First you guys need to understand this. So you yourself try writing this table, then you will understand. Once you understand this, then you will be able to understand the answer better.